Okay, the first question is just using our calculator, making sure that you know how to use it in the correct mode. Okay, in 3 SF. So that's the answer for question 1. I got 2.52. I think it's because when you key into your calculator, you press 3 sine. There is an open bracket automatically created for you for some calculators. You check, is it your calculator? Does your calculator automatically give you an open bracket? Yeah. Because if it does, it is expecting 55. When you key in, then you press +2. The calculator will automatically close over here. So the calculator thinks that you are trying to find 3 sine 57, which is not what the question wants. Okay, this gives us 2.516. But this is not the question. The question is 3 sine 55, then +2. Okay, so you need to understand how your calculator works. Yao Jin? You get the first one correct? Correct. Which one? 2.516 or 4.46? Then wrong lah. So this is wrong. Next question. Okay, second question, 3.46. How? Just press carefully lah. You have to make sure you have the open and closed brackets at the correct places. So you try again like this. Okay, in a fraction. Within the fraction, numerator cosine of 25, close bracket. Then plus sine of 45, close bracket. Denominator, tangent 25, close bracket. So 3.459. Okay, now, question 3. Put a star. Likely to be exam question. Basic exam question. So go on. You're doing a spa over there. Okay, so we have 90 degrees. Cosine BAC 9/41. As shown. Expressed as a fraction sine of BAC. Sine BAC, we have our opposite over hypotenuse. So now the opposite is over here. Opposite. I need to find the opposite value. Since this is a right angle triangle, which theorem can I use? Okay, Pythagoras theorem. BC plus opposite side, which is BC. We do so using Pythagoras theorem. We know the value of AB and AC. So BC, we square it, we get AC squared minus AB squared, which is now 41 squared minus 9 squared. We get 1600. So in this case, BC has a value of 40 cm. Replace that with 40. Now I can write down the value of sine BAC. Put it on the right side. Sine BAC. Opposite, which is 40, over hypotenuse, which is 41. That's all. This question is asking for the trigo ratio, sine BAC, which is simply 40 over 41. In your paper, take a red pen, write down, not finding angle. We are not asking you to find the angle. We are asking you to find the trigo ratio. Because if they ask you to find the angle, it will look like the next page. Find angle BAC, find angle PRQ, find theta. These second page questions are finding angles. In first page, I only want the trigo ratio. So leave it as the fraction. And then in part B, we need tangent ACB. Tangent ACB. It is always tangent, sine, cosine of an angle. The next part is always an angle. So opposite value, ACB. This is now the angle I'm interested in for part B. The opposite value is now 9. 9 over the adjacent, which is now 40. This is the value. Whole number, this is the answer. 9 over 40. Did you write 40 over 9? Then it's the wrong angle already. You used the wrong angle. Question 4. Information given, find tangent ACB. So identify where your tangent ACB is. A, C, B. Part A. Tangent. So we have our opposite. Opposite to this angle is 15. Adjacent, 8 cm. Can write mixed fraction if you want to, but you can leave it like this. Part B, sine ACB. Sine ACB. It is the same angle. Sine, opposite. This time over the hypotenuse of 17. And then in part C, cosine BAC. Different angle this time, BAC. So cosine will be our adjacent. Adjacent having 15 cm over hypotenuse. Turns out these two values are the same. Because, why are they the same? Because ACB plus BAC, they add up sum equal 90 degrees. That was the investigation that we found out a few weeks back. That is why their sine and cosine, they add up to be, they end up being the same answer. Sum equals to 90 degrees. So the last one on this page, sine x. Part A, opposite 6. Hypotenuse 10. So you must simplify to 3 over 5. Cosine y. Adjacent 6. Hypotenuse 10 again. Same answer again. Yes. Tangent y. Opposite 8. Over adjacent 6. So 4 over 3. Sorry? Okay, same thing. 1 and 1 over 3. Same. Next page. They are finding angle. So we need to use inverse. We need to use the inverse of trigo. So here we have one angle, theta. This is the opposite side. This is the hypotenuse side. So if the opposite and hypotenuse, which trigo ratio do we use? Tangent, cosine, or sine? Sine, because it has opposite and hypotenuse. Sine angle 5 over 13. So sine angle is 5 over 13. To find the angle theta, just sine inverse. Then use your calculator for this. Answer in one decimal place. So this is the inverse. Angle BAC. BAC. So we have one side, 7 cm. With respect to this angle, this is called the adjacent. Here we have the hypotenuse because it is the longer side. So adjacent and hypotenuse, which trigo ratio do we use? Adjacent and hypotenuse, which one? Which one is the A and the H? Cosine. So write down the angle, the trigo cosine of the angle BAC. Cosine angle is 7 over 25. So BAC must be cosine inverse 7 over 25. One dp again. So here is the inverse. We use inverse when we are trying to find the angle. PRQ. So it is a Q. PRQ. Identify the angle. And here we have adjacent as 4, opposite as 3. Yes, so we use tangent because you are opposite and adjacent. Tangent of the angle PRQ. Opposite over adjacent. PRQ. Tangent inverse. 36.8699. Okay, 36.869. 1 dp. Last two questions. Okay, first we need to find angle ABC. ABC found over here. We will look at the big right angle triangle. To find this angle with the 52 and 11.7. With reference to this angle, we have opposite and adjacent. So form the trigo ratio with opposite and adjacent. Tangent ABC, opposite 5.2 over the adjacent 11.7. So our angle ABC is inverse tangent. Because we are trying to find angle, so we need to inverse 5.2 over 11.7. $24.0 1 dp. Okay, so part A done. Next we need to find the length of CD. We already have the length of for those of you who asked me about this question, right, especially Ahmad, you asked me about this question, right? Then I think somebody said we can calculate the length of BD. Once we have that length, we can find the distance of BC, then you subtract, and then you get the answer. Yeah, that's one way. But there are other ways of doing it. So I'll show you a different way for part B. Here we have another right angle triangle. Okay, I'm going to highlight it. This right angle triangle. For this particular right angle triangle, I can find out this angle. Because this is equal to 180 minus 90 minus 23.960. Okay, so we get an angle from the angles of a triangle. Sorry? So this value, 66.04 degrees. For the green color triangle, we have an angle 66.04. The one side, this is known now as the, change name already, change name to become hypotenuse. For this green triangle. And this portion, BC, which is what we want to find, is known now as the adjacent. So hypotenuse and adjacent. Hypotenuse and adjacent, we use cosine. So cosine of the angle, which is 66.04, is adjacent, which is CD, over hypotenuse 5.2. So one final step, CD 5.2 cosine 66.04. 2.1117. So 3SF 2.11 cm. One final question, we'll do it tomorrow.